Hi friends. Construction is one of the topics which most of the students avoid. Today, let us learn how to construct quadrilaterals using compasses and ruler only. I believe if you watch this video till the end, you will feel comfortable with this topic. This is the first question. Using ruler and compasses only, construct a quadrilateral ABCD in which angle BAD equals to 45 degree, AD equals to AB equals to 6 centimeter, BC equals to 3.6 centimeter, CD equals to 5 centimeter. Measure angle BCD. At first, let us draw a rough diagram. Suppose ABCD is any quadrilateral here. The measurements given are AB equals to 6 centimeter, AD also equals to 6 centimeter, BC is 3.6 centimeter and CD is 5 centimeter. And angle BAD is 45 degree. So let me use a ruler. So I draw a line segment of 6 centimeter length and extend it so that construction of 45 degree becomes easy. So here, from here till here, it is 6 centimeter. So 1, 2, 3, 4, 5, 6. So here this is the point A, this is the point B. If you place the ruler and measure, you will find AB equals to 6 centimeter, right? So now let us remove the ruler and begin with the construction of 45 degree with the help of a compass. With A as center and a small radius, first of all, we draw an arc which is a semicircle and which intersects the line segment AB internally as well as externally at 2 points. With this point as the center and a bigger radius, we'll draw an arc above the line segment AB. With this other point in the line segment AB as the center and same radius, we have to draw another arc to intersect the previous arc at a point. Suppose Q. Now let us join AQ with the help of a ruler to obtain 90 degree at the point A. Next, let us bisect this 90 degree angle here. So placing the compass at this point in the line segment AB and a radius of any length, we cut an arc here and again with this point in the other arm of 90 degree as the center and same radius, we cut this arc. This point of intersection of the arc, when joined with A, the 45 degree angle is obtained. So now we have obtained 45 degree here. Next, we can see that AD is also of length 6 centimeter, right? So on this line, we have to measure 6 centimeter with the help of a ruler. So with the help of a compass and a ruler, we measure 6 centimeter and with A as center and 6 centimeter radius, we draw an arc to cut this arm of 45 degree angle. So we get the vertex D at this point and this length is also 6 centimeter. Next let us measure 3.6 centimeter. So placing the compass here, we measure a length of 3.6 centimeter and with B as center and radius 3.6 centimeter, we draw an arc. Next again, DC is 5 centimeter. Using the ruler and compass again, we measure 5 centimeter. So this is how we measure it, and this length is now 5 centimeter. So placing the compass at the vertex D and radius 5 centimeter, we cut an arc to intersect the previous arc, and thus the vertex C is also obtained here. Let us join the vertices C with B and D with C. Thus DC equals to 5 centimeter, BC equals to 3.6 centimeter. Thus ABCD is the required quadrilateral. The second part of the question says measure angle BCD. So with the help of a protractor, we will measure angle BCD. So you can see the center of the protractor is here, and this is the baseline of the protractor, and angle C is the interior angle of the quadrilateral. So now the center of the protractor to be placed at the point C, and the base of the protractor has to be collinear with the side BC of the quadrilateral. So let us adjust it properly. I hope you can see it, that the base of the protractor and the line BC are collinear. Now we have to start counting from here. 0, 10, 20. I hope you can see the measurements given, not from the right side, because we need the angle interior to the quadrilateral. So when we start measuring, we can see, please look at this red line. This coincides, this is collinear with DC, you can see, and we see that angle BCD has come out to be 60 degree. Angle BCD equals to 60 degree. This is the next question. Using ruler and compasses only, construct a rectangle ABCD with AB equals to 5 centimeter and AD equals to 3 centimeter. So let me draw a rough diagram first of all. Suppose this is the rectangle ABCD. The measurements that are given, AB equals to 5 centimeter and AD equals to 3 centimeter. Now what we have to think here is about the properties of the rectangle. The opposite sides are equal, so this is known, right? And each of the angles will be 90 degrees. So with the help of a ruler, first of all, I have to draw a line segment which is of 5 centimeter, and I have to extend it so that I can construct 90 degree properly. So here I have a line segment which is greater than 5 centimeter, but I am going to mark AB as 5 centimeter. So now this is AB equals to 5 centimeter. At the point A, first of all, let us construct 90 degree. So with the help of a compass and with A as center, we have to draw an arc which is like a semicircle. Now this semicircle touches the line segment AB produced at this point and AB at the other point. Now for construction of 90 degree, I will take this other point as the center and a radius greater than the previous one. I will draw an arc above in this way with same radius but with this point as the center. You can see on the line segment AB, I will cut the previous arc. So this point of intersection of the two arcs are to be joined. with a ruler with the point A. So we have constructed 90 degrees here. Now let me extend this line. Now with the help of a compass, we have to measure 3 centimeters. So taking 3 centimeter as the radius and A as center, we have to draw an arc to cut one arm of the 90-degree angle, and we have the vertex D here, and this is 90 degree. With same radius and B as center, we have to draw another arc. Next, D. Now with D as center and radius 5 centimeter, we have to draw an arc to cut the previous arc. This point of intersection of these two arcs is the vertex C. Now if we join them using a ruler, the construction of a rectangle is over. So here B is joined with C and the vertex D is joined with C. So we have BC as 3 centimeter, DC as 5 centimeter and AD as 3 centimeter. Thus, ABCD is the required rectangle. This is the next question. Construct a square having a diagonal of length 5 centimeter. So again, let me draw a rough diagram here. Suppose ABCD is the square and the diagonals are supposed to be of length 5 centimeter. We know the diagonals of a square are equal, so both the diagonals are 5 centimeter. But another property that is known to us is the diagonals of a square bisect at right angles, right? So they bisect each other. So using a ruler, first of all, I will draw a diagonal of 5 centimeter length, right? And this is the point B and this is the point T. I am drawing this diagonal BD and we can see the midpoint of the diagonal is 2.5. So let me mark the midpoint also. Now, keeping aside the ruler, we have to construct the perpendicular bisector of the line segment BD now. So for that, taking D as the center and radius more than half of BD, we have to draw an arc above and below the line segment. So this is more or less like a semicircle with the same measurement, and with B as center, we have to draw another arc so that the previous arc is intersected at 2 points. Using a ruler, if we join these 2 points of intersection, we see that it passes through the midpoint of the line segment BD. So this point is extended using a ruler and a pencil, and now we will use a compass and measure 2.5 centimeter so that we can find the other diagonal. So if we cut it here and here, we see that this point is the vertex C and this point is the vertex A. right? So let us join. So AB, DA and DC are joined, and we have this square where each of the diagonals are 5 centimeter in length. Thus ABCD is the required square. This is the next question. Using a ruler and compasses only, construct a rhombus ABCD of side 4.6 centimeter and angle BCD equals to 135 degree. So let us first of all draw a rough diagram to find out what is given. So ABCD is a rhombus where each side is 4.6 centimeter because all sides of the rhombus are equal and opposite angles are equal. Now here angle BCD is 135 degree. So this angle is supposed to be 135 degree. So let us begin. First of all, we will draw a line segment of 4.6 centimeter length. So this is 4.6 centimeter length. I'm going to mark this line segment as CD, and at the point C we have to construct 135 degree. The construction of 135 degree has been already explained in my video related to constructions for standard 8. You will find there how construction of 135 degree is done. Now for construction of 135 degree, we need 120 degree plus 15 degree. Now this 15 degree will come as a bisector of 30 degree angle, and the 30 degree angle comes as the bisector of 60 degree angle. So first of all, let me extend the line DC towards the point C. It will be easier for us to construct 135 degree. So for this, with C as center and a small radius, we have to draw an arc to construct 120 degrees first. So now with this point as the center and same radius, I will draw the first arc giving me 60 degree. This point of intersection as the center and same radius, I draw the next arc giving me 120 degree. So if I joined this point of intersection, suppose P with C, I will get 120 degrees. So let me join the arms. So let me join these 2 points and extend to show the construction of 120 degree. Now the remaining angle is 60 degree, which is to be bisected to obtain 30 degree. So what we have to do, using a compass and with P as center and any radius, we will draw an arc here, and with this point as the center, which is external to the line segment CD, we have to draw the second arc here. Now if we join these point of intersection of the 2 arcs with C, the construction of 30 degree will be over. So let us join and produce. Now again we have to bisect this 30 degree angle with any radius we like. Over here, suppose I am reducing the radius so that I have a neat and tidy diagram here. I'm drawing one arc here. Next, with this point P as center, I'm drawing another arc to intersect this arc. Now if we join the point of intersection with C, we can see that we have obtained 15 degree here. So this point from here till here, it is 135 degree construction over. I'm marking this as Q, suppose. So angle QCD is 135 degree. But I can also see that the line segment BC is 4.6 centimeter in length. So I'll take the compass and measure 4.6 centimeter here, and now with C as center and radius 4.6, I'm cutting the arm CQ at the point B. So this is the point B, and BC is 4.6 centimeter. Next, again with the help of the compass, we have to measure 4.6 centimeter only and draw an arc from the point B here. This arc is to be intersected by the next arc with B as center. So here we have got the other vertex, that is A. Let us join the vertices with the help of a ruler. So here I am joining AD and BA. Thus we have the rhombus ABCD. So here at this point we have 135 degree, CD is 4.6 centimeter, AD is also 4.6 centimeter. Thus ABCD is the required rhombus. The next question is, the perpendicular distance between the pair of opposite sides of a parallelogram ABCD are 3 centimeter and 4 centimeter, and one of its angles measure 60 degree. So let me draw a rough diagram first of all. Suppose this is the parallelogram. Okay. And we have to draw a perpendicular that gives the shortest distance between the point A and the side BC, and another perpendicular to the other side DC extended, suppose 3 centimeter. Because here it is said that perpendicular distance between the pair of opposite sides. So let us start. At first, let us draw a line of any length and mark a point A from where we are supposed to construct the 60 degree angle and also the perpendiculars to the opposite sides. Now let us construct the perpendiculars first. So for that, with A as center and a small radius, we will first of all draw an arc, which is just like a semicircle on the line. Now with this point as the center and radius greater than the previous one, we will draw an arc above the line, and this arc we are going to intersect by another arc by placing the compass at this point, means with this point as the center we are drawing the next arc. So we are getting the 90-degree angle at the point A when we join the point of intersection of these two arcs and produce it, right? So now we need to draw a line parallel to this baseline at a distance of 3 units from A. So for that we need the compass again, and with the help of the compass we have to measure 3 units now, and we will draw a line parallel to the baseline. So here with A as center and radius 3 centimeter, we'll draw an arc here, right? With another point here as center, we will draw the second arc. Now using a ruler, if we can accurately draw a tangent touching both these arcs and produce the tangent properly, we will get a line which is parallel to the baseline, right? So this line which is parallel to the baseline will turn out to be a portion of the opposite side of the parallelogram. Now let us construct 60-degree here with A as center and some radius. If we draw an arc and then take this point as the second center and draw another arc to cut this arc at this point, and we join this point with a ruler and produce it, it will meet the parallel line at the vertex D. So we have got this point as the vertex D. You can see this rough diagram. So this has to be the point D, and this gap between the two parallel lines is 3 centimeter. Now if we extend this line and construct another 90 degrees at A with the help of a compass, we will get the other pair of parallel lines. Now with A as center and a very small radius, let us draw an arc which is more or less like a semicircle. Now with this point as the center and a radius greater than the previous one, let us draw an arc here. With this point as the center now, same radius, we will intersect this arc. Let us join the point of intersection, and produce. Now this perpendicular line should be of length 4 units. So when we take the compass and measure 4 units and placing the compass at the point A, if we draw an arc now, so this length is 4 units. Let us shift the center to somewhere here and draw the second arc. Now if we draw a tangent, common tangent to these two arcs and produce them, we will get a line parallel to AD, right? So you can now see that we get the point B here and we get the point C here. Thus ABCD is the required parallelogram. So this gap is 4 centimeter here. This is question number 6. Draw a parallelogram whose diagonals are 6 centimeter and 4 centimeter long and contain an angle of 75 degree. Measure and record the length of one of the shortest side of the parallelogram. So let me draw a rough diagram first of all. So here suppose ABCD is a parallelogram. According to the question, we need to draw the diagonals which are 6 and 4 centimeter in length, and we know that the diagonals of a parallelogram bisect each other. So 2 centimeter on this side, 2 on this side, 3 on this side and 3 on the other side. It also says that an angle content should be 75 degree here. So let us start. So first of all, using a ruler, I will draw a diagonal which is of length 6 centimeter and mark its midpoint. So suppose BD is the diagonal of length 6 centimeter and the midpoint is 3 centimeter here. Now using a compass, we have to measure 2 centimeter to draw the other diagonal. But before that, construction of 75 degree is necessary. So to construct 75 degree angle, we need to show a 90 degree construction and remove 60 degree from there so that we are left with 30 degree. This 30 degree when bisected gives 15 degree. So 60 plus 15 degree can give us 75 degree. So at the point O, let us construct first of all the 75 degree angle. So with O as center and a small radius, first of all, we will draw an arc which is a semicircle here. Then for the 90 degree construction, we will take this point as the center and a radius greater than the previous one. We will draw an arc here. With the same radius and the other point as the center, we have to intersect the first arc. Now if we join them, the 90 degree construction is over. If we join the point of intersection of the two arcs with the point O, 90 degree construction is over. Now from this 90 degree angle, we have to keep aside 60 degree. So with O as center again and any radius, any small radius, we will construct the 60 degree angle. So in this way, and with this point as the center, and we will intersect this point. So here if we join using a ruler, O with the point of intersection of the two arcs, so we are getting 60 degree on this side. Now this remaining 30 degree is to be bisected. So we will take the compass again and with this point as the center and any radius, we will cut an arc here inside this 30 degree angle. With this other point as the center, we will draw the second arc to intersect the previous arc. Now if we joined O with this point of intersection of the two arcs and produce, our construction of 15 degree is over. So with this we have constructed 75 degree angle. Now this diagram might look a bit untidy, but each of these steps are important to show the construction of 75-degree angle. Now this 75-degree angle has two arms, right? So one arm is already a part of the diagonal BD. The other diagonal can come from this arm if we extend it further. Now with the help of a ruler and a compass, we will measure 2 centimeters. So after measuring 2 centimeters, we have to draw an arc here, an arc. So the other diagonal is also obtained now. So this is the point C here, and this is the point A here. So this length is 2 centimeters here and 2 centimeters here. Over here it is 3 centimeters and 3 centimeters. Using a ruler, let us join the vertices C with B, D with A, B with A, and again C with D. Thus, ABCD is the required parallelogram. Now, the second part of the question, measure and record the length of one of the shortest side of the parallelogram. So, we have to take the ruler and measure its length. So, let us take the ruler. Either you take the help of the ruler, or you can also take the help of the ruler and the compass. So, this measurement from here to here, it is AD. So we can see that one of the sides is 3 centimeters here, and for the other side again AB. So now to measure. It is 4.1 centimeter. So this is 4.1 centimeter. So the shortest side is of length 3 centimeter. The shortest side is of length 3 centimeter. So the next question is construct a hexagon of side 5.5 centimeter. So I am going to show you an easy process. We know that a hexagon has 6 sides, and each of the angles of a hexagon should be equal to 120 degree. So it can be done by construction of 120 degree and then intersecting 5.5 centimeter on the arms of 120 degree angle, and then getting a hexagon. But I am going to show you an easy way out here. First of all, using a compass and a ruler, we will measure 5.5 centimeter and mark a point O. So let us measure 5.5 centimeter with the ruler and a compass. This is 5.5 centimeter. Now with O as center, we will draw a circle. With the same radius, we will place the compass at a point here at a point on the circumference of the circle, and with this point as the center we will now draw some arcs. Again, with this point as the center we have to draw the next arc. Then with this point as the center we will draw the third arc. The process goes on. So we have got 1, 2, 3, 4 vertices. This is the 5th vertex, and we have already marked here the 6th vertex, right? So all the vertices are found out. Let us mark them as A, B, C, D, E and F. Using a ruler, let us join the vertices now. E with D, C with D, B with C, A with B, F with A and E with F. So how easily we could draw a hexagon of side 5.5 centimeter. And if you measure the angle, each of this will be 120 degree. So this much for today. In my next video, I shall come with more constructions. Till then, stay safe, take care, good day.